Run length encoding technique is used to encode common symbols in a sequence. For example, I prepared for you 3 examples here. So in the first example, we're trying to encode some word, this sequence, for example, but we know that our alphabet consists only of 2 symbols. It's binary alphabet. So we can transmit then only counters if we know the order. For example, here 5 ones and 3 zeros will be encoded like that. In the second example, we can replace long enough runs with tokens. Each token consists of an escape sequence indicating start of a run, the length of the run, and the symbol itself. As here you can see, CB are too small. We do not encode them because it's not. Encoding them will take up more space than just transmitting them as they are given. We encode here's a sequence of 5A, so we encode escape from sequence 5 here because there are 5 A's and the symbol, and in similar fashion we work with the sequence 4th. And the third example is useful between very common symbols and other sparse symbols in between. For example, here are 4 zeros, then 2, once again 2 zeros, then 1, then 10 zeros, and then 5. And thus we encode it as 4, that refers to zeros, 2, that refers to a sparse symbol that separates one piece of a sequence from another, from next part of zeros, then 2 once again for 2 zeros, and 1 and 4th in similar fashion. I will present you an algorithm which is really used, the run length algorithm, which is really used in bzip2. As always, this is the formal definition of the algorithm. If you need this algorithm, I recommend you to write that down and follow my example. In this algorithm you also should use the symbol and the number of times it has been seen. If there is only 1, you just leave it alone. So, let's make an example for this A42, right? First of all, first R will be 42 divided by 2 minus 1, that equals 20. And thus CI will be 42 minus 40, right? This will be 2, so this will be run B. R2 equals 2. Try it yourself if you want. I recommend trying it yourself after you are having an example. So 20 minus 9 multiplied by 2 equals 2 once again, right? Run B. And the last step. This is 9, okay? Minus. So this will be, we can also encode that, but for the example I've just chosen this place that we encode. This particular place that we encoded will be this sequence, run B, and run A, and that's it.